the diagram shows an AC waveform that's displayed on the oscilloscope screen. The time based on this scope is 1.5 milliseconds per division, and the wide gain is 1.5 volts per division. For the AC waveform shown, we've got to calculate the frequency, the peak voltage, and the RMS. Okay, so here we go. What I've got then is this wave, and they've given us 1.5 waves, like this. Now, this distance from here to here is 10 squares, and they've told us that is each of them is 1.5 milliseconds. So that's 10 squares. Therefore, I've got 10 times by 1.5 times 10 to the minus 3 seconds, which is equal to then 15 times 10 to the minus 3 seconds, or 15 milliseconds. So the whole duration from there to there. The first bit they want us to find then is the frequency. So we know from there to there is 15 times 10 to the minus 3 seconds. So the time period for one wave then is going to be 15 times 10 to the minus 3. But that is divided by, you've got 1.5 waves there. So that is going to give me, 15 divided by that is going to give me 10 times 10 to the minus 3 seconds. Frequency is 1 upon the period, which is therefore going to be 1 divided by 10 times 10 to the minus 3, which will be 100 Hertz. Now the question on this normally is going to be along, well, why did I actually use the whole lot? Well, this is an odd number of squares. It's 2/3 of the way along, so it's going to be about 6.667 squares. It's going to be much more accurate for me to actually say I've got 1.5 whole waves across 10 squares than it is to try and read 6.66667 off of this thing. So it's a way of actually reducing my uncertainties, and a much more accurate way of actually calculating it. So once we've got that, it asks us to calculate the peak voltage. So if we go back and look what they've given us, we've got 2 squares up here. And so that means I've got 2. It told us each square, the voltage gain was 1.5 volts. So that's going to be therefore 3 volts. So part 2 then is going to literally be 3 volts for the peak voltage. Now we've got it's asking us then for the RMS voltage. Now we've got a sinusoidal wave, so we know for a sinusoidal wave to get the RMS value, the root mean squared value, which is the effective energy transmitted if it were DC. The RMS then is 3 divided by root 2. Shove that into a calculator. 3 divided by root 2 gives me 2.121 volts. Now if I look at it, I'm going to say there actually, a better way of saying this, I reckon that was 3.0 volts. I reckon that therefore was 3.0 volts, because I'm reading, I can say I can read to at least 1 decimal place beyond volts. So therefore I got 2.121. I'm going to stick with the 2 significant figures, so I've got 2.1 volts as my answer for the RMS voltage. Hope that helps. Thank you very much.